Good morning. I am Chris. This is Jamla. We are from HasGeek. Welcome for the workshop. Right now we have three Wi-Fi networks. This is guest 1 and guest 2. So please don't use one network. Use any of the other one because it will get choked up. So next we will have Olivier. Over to you.
Thank you. Thanks for the intro. Welcome to this workshop. My name is Olivier. We're going to talk today about creating automatic testing. So before I get started, I'll just introduce ourselves. So I'm here with Mano over there. We're two of the co-founders of Blockbuster. We're a startup based in Switzerland. This is why we're in Swiss today. We are hosted by our fellow friends from Swiss. We're coders. We have backgrounds in dynamic analysis, the web, and JavaScript. Actually, our product is direct evolution of the research that we're doing on dynamic analysis at UPFL, which is the school in Switzerland. Before we start, let's just small quiz. What do you know about Switzerland? What is the first thing that comes to your mind when you hear Switzerland?
Well, definitely Swiss chocolates.
Swiss chocolate, great. So we have Swiss chocolate, right? So we're going to do a few challenges later on. So if you're good, you're going to get some of the best Swiss chocolate.
So basically you should have said watches because we have a bunch of products. But it's going to be Swiss chocolate.
If I say Benz, will you give me some?
I said a watch of everyone.
We keep it.
So what is Blockbuster, right? So Blockbuster, it's the name of our company, but it's also the name of our product. It's a robot for exploring JavaScript and HTML. We'll go into the details of it later on. Basically, the idea is to improve the quality of your application by helping you to test more with less effort. Hence the name of the workshop, automating the automated tests. It's a very new product. It's still in beta, so we launched the public beta in June. We now have 300 users, so it's going pretty well, but it's very young. And this is the first Blockbuster workshop, so I have to do one very, very important thing. I have to live tweet. So I'm going to take a picture of you. Get a smile. Okay. Nice. Actually, that was the wrong thing. Smile again. Just to prove that we're doing a workshop. Thanks. So what are we going to do today? So we're going to basically talk about testing in general, but really the goal is to help you do things with the technology that we are producing and help you basically get a feeling for what it could allow you to do differently in your testing workflow. So there are going to be three parts. The first is going to be an introduction on testing. The second one is going to be about unit testing, where we'll basically cover the basics about unit testing and talk about Unite, which is a new thing from Blockbuster. And then the main part about integration testing, where we'll talk about what we do in our main product Blockbuster, and we'll compare that to But as I said, the goal is to be really hands-on, so we're going to try to do not too much theory and let you play with these things, so that you can really feel it by yourself. Tomorrow I'm also giving a talk, so there's going to be some overlap between the workshop and the talk, obviously, but tomorrow it's going to be a bit more about the theory behind what we do. So let's get started. If you want to follow the workshop, you can actually get this presentation and I think there's a few examples on GitHub. So it's at this address. You can get it now. So this is where you have the slides. Alright, starting with the introduction of testing. sure we all agree on that. What you can hear sometimes is that the purpose of testing is to prove that your software works. I don't know if you agree with that definition. Everybody agrees with that?
Yeah.
Yes? Sure? Really? No chocolate, sorry. No, we don't agree with that the definition. Actually, we think that the purpose of testing is to show that your software does not work. Right? You cannot prove anything with testing. You can only basically try things and hope that you tried enough things so that you don't have defects that are lying around. But this is not a proof. This is just sort of an experience, right? So what you have to do with testing is you have to test as much as you can, because there will always be a chance that you're missing something. So, what should you test for? Well, you can test for basically anything. You can test your code for technical errors, basically exceptions. You can test your functionalities, your business logic, make sure your application is computing the right thing. You can test the compatibility with browsers typically. You can test the performance, make sure it's fast enough. You can test the security, make sure nobody can break into your code. You can test your usability, make sure it's easy enough to use that your users don't get lost. Probably a lot of different things, right? For all of these things, there are different type of tools, there are different challenges, different methodologies. What we're going to cover today is really testing your code and testing your functionalities. These are basically the main things that we do at Vector. Reload, because otherwise it's always spoiler. So, what are the testing methods? Obviously, you can test manually. I guess everybody tests manually on top of whatever other type of testing we do, but this is really not the point of this workshop. So we're going to talk about unit testing. The goal of unit testing is to test a small part of your application in isolation from the rest of the code. And then we're going to talk about integration testing, where you test the entire stack. So when we talk about JavaScript or the web, well, that means testing your front end, your back end, and whatever else is involved. The database, other services, that kind of things. Now there are recurrent testing challenges. Whether you're testing, you're doing unit testing, integration testing, they're basically the same issues. Right? The first is time and effort. It takes time to write test cases, and it takes sometimes even more time to maintain these test cases over time. Right? Because every time you modify your code, some of your tests are going to become obsolete, or worse, they might actually report errors where there are none, so they'll basically create false positives. Another challenge is insufficient coverage. Right? If you write one test case and you have 1 million lines of code, you're not covering anything, right? So that's a challenge. There are other challenges, but again, these are the ones we're going to cover. What our technology does is it basically analyzes your code. It tries to help you come up with other combination of inputs that you could use in your tests. Right? And that's useful if you're writing unit tests and also for integration testing, where in this case it actually explores your code completely automatically. This helps you reduce the efforts, so spend less time on writing and maintaining test cases. It helps you improve your coverage. The combination of these two things basically leads to improved quality in your code. So that's it for the overview on testing, and now I'm going to start talking about unit testing. Alright, so who is familiar with unit testing here? Sort of? Who's tried it before? Yeah. Almost everyone. Okay. So there are several goals when you do unit testing, right? First is find problems early. It's the main goal. You want to know about the bugs before your users do. So you write test cases and then you run them so that you find this problem, and then you run them again and again when you have new versions so that you prevent regressions. Right? So your test cases tell you when something that used to work doesn't work anymore. The third goal is actually to document the code, especially for the web or for JavaScript. your unit tests are actually a good way of documenting the expectations of your code. The main principles are very easy, right? You want to test the units, so a small piece of your code in isolation from the rest, so that you can identify the problems in that piece of code and that piece of code only. You're not interested in knowing about what other things can happen to the rest of your systems. That's the first principle in testing, unit testing. So you have to abstract away the rest of your implementation, otherwise that doesn't work. So you need to be able to extract this unit from the rest and testing, test it by itself. The other principle is you want to ensure reproducibility. It's not interesting to write a test case that you can run only once, right? You want to be able to run them over and over again. So that means you need to keep the application state clean. For that, you're gonna have to basically clean up after yourself, right? So when you run your test, you make sure if that unit modifies some state somewhere, you clean it up so that you can rerun the test in the same conditions. In terms of tools, there are basically a million of them, right? So there's, for JavaScript, there's JustMine, YUI test, Mocha, Browse, many others. They all do basically the same thing, right? They give you a syntax and a set of routines that you can use so that you can code, your unit, and verify the expectations. Going into a small example, this is an example with Jasmine. In Jasmine, you create a test suite, which is basically a collection of different test cases by calling this describe method, give it a name so that you know what test suite you're talking about. Then you define a test case with this int method. Again, you give it a name, and then you call whatever code you need to call to do the testing, and then you encode the expectation. So here it's a very trivial example where I'm calling a function and verifying that it returns the right value. Very simple. Now that's simple, but then, well, there's still a few challenges, right? In that example, it's pretty obvious. You have one method, there is no side effect, so it's simple. But in reality, it's not like that, right? So your code is going to call other things, other dependencies, libraries, sometimes databases. So you need to be able to separate the unit from the rest and then mark the dependencies. So this means, if your code expects something from a library, you want to test this piece of code, not the library, so you need to emulate the behavior of the library so that your code still understands it and you can test it in isolation. The two other challenges I've already talked about. Coverage. Well, how do you know that calling your function once is enough? Maybe you need to call it 5 times with 5 different sets of parameters, or maybe you need 20 or 50 different type of inputs. And then maintenance. Well, if you've actually gone into the trouble of writing 50 test cases, somebody changes something in your code, you don't want to rewrite these 50 test cases. So that's a third challenge. In all three cases, there is one requirement. You need to understand your code very well, otherwise you cannot do meaningful testing. And that's where it gets difficult, right? Because if you look at your program and you sort of plot it in a way, it will look like something like this, right? This is basically a control flow graph. So each node here represents a piece of code, and then you have the if statements. For any piece of non-trivial code, this graph is going to be huge, right? Then when you write a test case, you're doing something like that. You're selecting one path into that graph, right? And then you're encoding expectations. Now, if you're lucky, you're going to find a bug like this, right? Maybe not right now, but maybe a week or two from now, rerunning this test will uncover a bug or a regression. That's the purpose. That's why you're doing testing. But if you're unlucky, you're writing a test and that test actually works fine, but you have a bug somewhere else, and it's not you who's going to find the bug, it's your user. That's not what we want. Now, here's an idea. What if we could, when we're running a test, record basically, if my test here is taking that side of the if statement, then I'm going to say, no, I want to take the other side of the if statement, see what happens. So that's exactly what we're doing. So we're using a technique that's called symbolic execution. It's a technique that was formulated in the 70s, very theoretically. It's never been used until a few years back, basically because it involves solving problems that we couldn't solve before. It can be used to generate test cases completely automatically. So far, industrially speaking, it's been applied, as far as we know, by Microsoft. Actually, they've been using that a lot for finding bugs in Windows, especially in the file system of Windows. So that's called C++ application. NASA uses it a lot too for testing their rovers and stuff like that. So what's the idea behind symbolic execution? So I'm just going to go over it, sort of like this in an abstract way, and then I'll show you real examples so that you understand this better. So what symbolic execution does is basically it runs your program, and then it records the constraint on the input. So your function takes one parameter, and you manipulate this parameter, you're manipulating input. It records all of that, and it encodes that as mathematical equations. And then every time there's an if statement in your code, if that statement touches the inputs, then it records what side of the branch was taken. So if the if statement was evaluated to true or false, and it records the associated constraint on the input. And so these constraints, as I said, they're like equations, and they're going to be solved so that we can craft new inputs that takes the if statement to the other side of the branch. So if these equations can be solved, then we have new input. We can re-execute the program with different sets of parameters. That's basically the idea. So what is this good for? Well, it's good for understanding your code better, because it will actually try to take your program through various code paths. And these code paths may not actually work the way you expected. That's actually the main result we get from this thing. When we run it on a piece of code and we write, well, we realize that the code can do things we didn't realize. And so it can also help you generate or complete your testing trends. If you have one test case and then you run this thing and it shows that you have other input values that produce output that you did not expect, then that's a good idea to make a test case out of it to make sure and it continues to work well. You can also use that for refactoring. So when you're taking a function and you're rewriting it, because the code is not in good shape and you want to make it look nicer, but you still want the code to behave the same. You can actually use that to compare the behavior of the two functions and see if one can actually produce a result that the other cannot. If that's the case, then you have inconsistency between the two implementations, so you have something to fix. Alright, so far it's been fairly theoretical, so let's move on and do a few exercises. So today we're very happy to introduce Unite. Unite is a new playground. It's actually a subset of Bugbuster, our main product. It's something we built so that people can understand better symbolic execution, our technology, but it's also something we think will evolve into a full-blown product over time. So feel free to go online on unite.bugbuster.com. So it's a pretty simple thing. So you can input JavaScript code in there, in this main field over here. It's actually always working to resolve puzzles. So you have one function puzzle, that's a requirement. Actually, you always have to have this one function called puzzle. And we're telling the tool that it takes one parameter, which is called x, and it's a number, right? That's all we do. And then we click on run. You can see what it does. It says, oh, I can call my puzzle function with x, with the value of x, which is 0. And the return value of the puzzle function is going to be false. Or I can call Basel with the value of 1, and the return value is going to be true. So it's exploring the two sides of that bridge. While it does that, it also shows you the coverage. So if you hover over these two set of values, you actually see the lines of code that have been covered. So that's a pretty simple example here. Now let's make it a little more interesting. Let's say my function is actually computing something. So it's basically comparing the number to see if it's greater than 10. So now if I do that and I rerun, you'll see that it still produced the value x equals 0 and the method returns false, and then it produced a value which is greater than 10 and it returns true. Now let's say I still want to improve that thing, and I have a constant value here. Now I can continue working on my program, and I can say, okay, now if x equal my const, then I return undefined. Right? Now I rerun again, and for surprise, it still produces two values, right? See why? Pretty obvious. The constant is greater than 10, so there is no way to enter that into that third statement here, right? Now if on the other hand I put what happens? I think I just dropped my pen. So if I change the value of my constant to, let's say, 6, then I run again, and this time it finds the 3 inputs. 0, like before, 6 covers the return undefined, and so that's a pretty trivial example. Let's look at one that's a little more interesting. So we have a set of examples here that we can try. So here I have a checksum function, right? Can you guess what this function does? No? Good? Okay. So no worry. It's not obvious like this, right? It's actually a function we wrote in this way just to show you why it's interesting. So if you have this function, if you write this function, you know what it's doing. If you did not write this function, it's not that obvious, right? It's not very long. It's maybe 10 or 20 lines. It's not completely obvious what it does. So if your job is to write a unit test for that, what are you going to do? You're going to write, you call it with one value, see what's the return value, and then build a test case out of that. But if you're still not sure what it does, then it's going to be hard to have good coverage with the test cases for that. So if you run this into Unite, you'll see what happens. So it actually figures out the different path that this function can take. So the first value here, it inputs a string, that's A. The result is not even close. Right? That's what the function produces. And then it produces a second string, and then the result is no, try again. What happened here is it's produced a string that has a length of 5, so that it passes this expression here and only contains characters from E to Z. But it could not enter into that last if statements because basically the checksum is not correct. So then the last value here, then from the checksum. So that's an example where you have a piece of code that's a little less trivial than what I showed you before. Here, basically, it suggests you to write 3 test cases with 3 different input values that covers the vector tree. Now, I was telling you that this can also be useful for refactoring. So we have another mode in Unite that's called the compare mode. In the compare mode, you basically have 2 functions, one on the left and one on the right. And what Unite is going to do is going to try to find values that can make these 2 functions produce different outputs. So these are substring on a string. That's basically two functions that are available in JavaScript. So what do you think? Is Unite going to be able to find differences between these two implementations?
Yeah, it's like that.
Exactly. It has to be there.
Yeah, so that's a good thing. But any idea what the difference will be? That's actually something I didn't know either. But subscript, you're supposed to do exactly the same thing, but the parameters you pass to it actually work slightly differently. So if I run, this thing, then you'll see it produces two values. The first value is x equals a. Then the two functions return exactly the same thing. They return a. Now the second value, which is actually it's 4 characters that you put. It's \r. These are basically non-visible characters, but it doesn't matter. You can try with eggs; it will do the same. Then the result of the first function is only 3 characters long, and the result of the second function is 4 characters long. So you have a very subtle difference. So that I think is fairly typical of something that can happen during refactoring. Right? You're rewriting your code. For some reason, you're replacing subs by substring, maybe not even realizing it, right? And you're introducing a bug because now the function does not behave the way it was behaving before. All right, so let's make you work a little bit. We have another mode, which is called the challenge mode, which we built in order for people to be able to exercise with this thing and understand how it works. So it's basically the same as the compare mode, except that it's hiding one of the two functions. Right? So if you run that, you have it will basically run the two functions and try to see if you can match the two behaviors. And if I just run that simple example over here, it shows that with an input x of 0, the result of both functions is 0. But if you input 3, then the result of the two functions is different. Right? So the first one who guesses what the value is gets chocolate.
X squared.
X cross X.
X
X
squared.
plus X. So who said it first? I think you can give two.
Who was maybe a second one?
Alright, so I think now we can take a moment if you guys want to play with it. If you win more challenges, there is more chocolate. The others are not that trivial, so you can try. Otherwise, if you want, you can try to create a new puzzle here. So you can write your own function, see what it does. This is pretty new, so you might be able to confuse it completely. So that's another challenge. So yeah.
Maybe you can show the URL again. I don't know if you were able to.
Oh, yeah, did you catch the URL? It's unite.webmaster.com.
If you have a question. Well, that's.
Yeah, so some puzzles have hands. If you need help. Huh? Yeah, not just to get maybe how this thing works. Or I mean, if you want to try with your own
didn't. Oh, I don't know. What's the answer? That's correct. That's correct. Well done. So second chocolate for you. You see the next challenges are big problem. Like if you want to try the linear equation, it's your very good. The linear equation, that's a nice bit trickier. Have you tried the challenge number 2, for instance? No, if you go in the list of challenges, there in the class, the arithmetic number 2. This one is here. Finally. No, you did it again. You did it again. Let me see the coefficient.
It's too much chocolate is not good, right?
Oh, you gave me the wrong answer.
What?
Oh no, that's the first one. No, I thought it was it's the three. Wow.
That's really too easy.
Yeah. Yeah, we will stop at the
I
end.
think he's not getting enough competition. I think you just need to try harder.
Well done. Yeah, okay. This is the linear equation.
Yeah, I think you.
Yeah, you confuse the system
You
because
confused
you.
it, but that's actually correct.
It's a girl. Yeah.
Yeah, I think it's actually correct.
Oh no, it is because yeah, it's. No,
Yeah, no, that's correct. Another one?
Well done.
So he's taking all the chocolate home.
Yeah, there's still one chocolate left.
Let's try to keep it for someone else if you don't mind.
only JavaScript.
Yes.
And you have plans to extend this further?
In which direction? You mean doing backend or because this is really just a JavaScript, it's not even the DOM API, it's really a subset we put only up about the API at this
If I
level.
have a bunch of JavaScript code, can I perform an analysis on the cloud as in not copy paste code and stuff?
That's the idea.
No, we don't have, right now you're going to have to copy paste. We want to provide an npm command line on the REST API for you.
Because this is new and stuff.
Yes. But you can paste more code that is less trivial, but it's still in a web interface only. So there's an interface problem. And then we're also working to implement Shinx for Node.js API. So you can also try code that has some Node stuff. But currently, as I said, it's really a playground to sort of understand what this thing does, how it works, and what it will do for you. So if you have interesting ideas or things you'd like to do with it, just let us know. It would be really interesting to hear about. Okay? Okay, the last part of the workshop about integration testing is going to be done by Arnaud.
Okay, so now I will talk about integration testing. And so as Olivier told you already, integration testing, the idea is to test your system with more than one module, and in most of the cases, you will test your system with the whole stack. The number one open source solution out there is Selenium and WebDriver. And what Selenium and WebDriver gives you is a way to script your browser so you are able to tell the browser to do something in a very exact way. So if you say, now you load this page, now you click there, now you have something like that. It supports many browsers, so it's multi-browser compatible, and you can use different languages to write those test scripts because they are transformed into what they call the remote web API that lets you contact the browser, so it can be done in Python, it can be done in JavaScript, etc. So I will just give you the canonical Google example that is used everywhere. So Google is certainly the most well-tested website with all those WebDriver scripts that you can find around here. So this is just a power place where you create a new remote WebDriver and you give the capability. And then we will go through a simple test. We want to search for something and make sure that the title of the page contains the search keyword that we entered. So it looks like that. It's maybe not easy to read, so then you go through it. So you start the browser, you load the page. One bit, well, I would say that afterwards. You get an element from the page, and each time you have to go back, so you have to wait for the next go back. Here you save the element, that's going to be the search box. And then you search I think it's the search button. And when you have all that, you can type into the search box WebDriver, and you can click on the element to do the search. Then one bit of information, it has been done in Switzerland, and with Google, when you go to google.com, you're redirected to your country version. So you get in the title, you have to search in Switzerland for WebDriver dash, then Google Suche, which is German. That's just, but then you can assert that with the search that the title is what you were expecting. That's the simple case. That's even too simple. So when you try to do something like that on a real life example, this is an application that we were mandated to test. It's a huge form that you fill up to ask for a grant at the Swiss CTI. So CTI is the arm of investment, the Swiss for what's the exact CTI? It's
Commission for Technology and Innovation.
that's it. So basically, you have this huge form and you have different sections where you have to type something inside. So what we've done is basically to verify that the save button is available, that the save button is enabled, because by default it's disabled, and when you change the state of your form, the save button will be available. So what you need to do is, it's pretty simple. You just type something in a text field, wait for the AJAX to go, because it's a highly asynchronous application, so you type something, the information is sent to the backend, and then you verify that the save button is enabled, and you repeat that for the next element in your field. So it's quite long, but sounds easy. In fact, it is easy, but it is tedious. So it took us 280 lines of code, more or less. I can show you the script. It's really easy. It's just straightforward. You just go over the different elements and you do what I've explained before. So it's long, and the longer your script is, I think it's this one. Sorry. Yeah. The longer your test script is, the higher the maintenance will be, because you have more, CSS selector to make sure that they don't change, and if one of those selectors change, then you have to fix your code. Okay. So now, if we look at what we were able to achieve with Blockbuster, we went from 280 something to 20 lines of code. So no need to understand the code now. I will go through the different key concepts of the API afterward, but you can see that we shrink this code up to 20 lines of code. Since I'm not really a good salesman, I have to say that this is a case where it's a good case for us, because there's a lot of repetition. You have a long list of items to do, and you have to go one after the other. This is the ideal case to reduce the number of lines of code, but you will see reduction of the number of lines of code in your test script when you use Blockbuster anyway. It's not going to be each time 10 or 15 times more, but it's going to be smaller. So Blockbuster is a tool that will explore your application, and while it's exploring the application, like a human would do, so it will open the browser and type the user stuff, click on the button and stuff. While it does that, it will report all the technical problems that it can find. It has also an expressive, time-insensitive JavaScript API that I showed you, that those were the 20 lines of code. And the goal is to test more with less code. So how does it work in practice? You will load Blockbuster will load your application and will start to figure out what are the actions it can do. It can maybe click on a button, it can type something somewhere. This will trigger some event incident that will be analyzed by our dynamic analysis system, which is the heart of United. Just so it's the same stuff. You have the code. United will go through it, figure out what are the inputs, and then it will start again the process. So it will maybe type something somewhere, click OK, figure out that you could type something else and re-enter a different value. If we take an example here, it's a very trivial example. So we have a sign-up form with an email address and a sign-up button, and some validation code. So the first thing it will do is type something in this text field. Nothing will happen because no event handler has been triggered. And then it will type sign up. And there we will go through part of the code, but since the email validation does not go through, it will stop there. Then based on the expression, this regular expression, it will generate another input that is valid in terms of this email, this regular expression. It might not look exactly like an email address that we used to, but if you look at it, you have the @ you have the number of characters which match whatever you have here. And this will cover the rest of the function as soon as we click on the sign up. Okay, so what we will do now is to create an account on the Bugbuster and see it live. So I invite you to go to bugbuster.com. So there, and we will create an account together. We will be working on the kitchen sink, which is a small example that we've built. Okay, so that's the kitchen sink. You should be on bugbuster.com. It looks like that. You have a big fat green try Bugbuster button there. So you can click on it or just scroll down. And here you can fill up the form. I will do it. Okay. So the system will send you an email to verify your email address. You will have to follow the link in the email. When you're ready, you can click on the create new account. And then you should receive an email like this one, where you will have to click on the link to validate. If you click on
Somebody saying that.
the first email you received was
It's just trying to spam or registering to accounts.
one email is nice. More today.
Yeah, it's it. That's its birthday.
Okay, so that's did not receive this email, the one last step. Maybe it's
You just have to wait, it's gonna come.
In July. Yeah, we.
Yeah, no, you need to sign up again. If you haven't activated your accounts,
I did, but I'm not able to log in. I don't know where to go.
it's at the Bugbuster account.
Okay. So we follow the link. Hopefully you receive the email. It might take a bit of time to receive the email.
I think they are. Sure.
So saying that my email has been validated. So now I will log in. So if you had an account before the address is at first time you log in, you will be presented with this wizard that you create your first project. The idea is that you can have many projects, one per application, or if your application is really big, you can even have many projects for one application. So I will go ahead and name this one JS Food. JS Food Workshop. And you have to put a URL. This is the base URL where you will be doing the different examples that we are going to do today. So I will put the kitchen sink.
So if you want to follow the example, it's a good idea to do the same like that.
Yes. Okay, then I will click next. Now I have to talk about the email validation, the URL validation. So we want to make sure that you are testing your application, not an application you don't own. So we ask for URL validation. In the case of the kitchen sink, it's validated for everybody. It's like a playground. So you should have a green OK icon there. If it is not the case, then probably you misspelled the URL. If you want to add other URL to your project or create other project, you will have to go through the simple URL validation. So basically you have to copy at the root of this address this file. The file can be empty, it has no meaning, it's just that we are doing a head, an HTTP head on this file to verify that you are able to modify your application. If you cannot, because you are working for, I don't know, a company where you don't have access to the public-facing web server, which is often the case, you just send us an email that we have a link that will give us all the information that we need to manually validate URL, and we can do that afterward. For the moment, we'll use the kitchen sink for the first example. So I will go ahead and click on the hold down.
So is the kitchen sink like a sandbox like we have?
Yes. And it's going to evolve with the time. For the moment, it's more or less a replicate of bugbuster.com, the website. So I will show you the kitchen sink. I think I have So it looks like that. It's pretty much the same layout. You have a scroll button, which is in our website, the register button, and that's pretty much our website. And you have a sign up form. So I just want to make sure that everybody is on the same. So this is the main view of Bugbuster. You have here a set of what we call scenarios that are test scenarios. And I think the simplest is to show you one. So I will show you this one. I click on the title, and this will go into the edit mode. So this is a very simple scenario where all we give is the URL of the page you want to test. So this will do an exploratory test of your application. So now you can click on the start button next to the exploration testing. And this will start the exploration of it can be a bit what we are seeing here is that one of the test session is currently running. So we can go to the exploration tab to see more in detail what is happening. So there we see what the robot is doing. So the robot is completely free, just loaded the page. This is the first action it did, it loaded the page, and it reached these states. This is the page as you load it. Based on that, it will try to do some action, click on different elements and try to see if it triggers something. And it will go like this, clicking on different elements and exploring the application. So there are a lot of things that you can do on one web page, of course. And at some point, I guess, down in the flow of exploration, it will stumble upon a problem. What is that?
Yeah, sorry to interrupt, so not so fast.
So this is one problem. There should be another one. Okay, I want to talk about this. Now let's start with the exploration. So here we see in the exploration that let me go back. It typed something in the field there. So the green dot is where the robot does something. And there, yeah. And it found a problem. Here there's an undefined is another function, which I think everybody agrees. And there was an HTTP problem of 400. So we can go to the tab section with the bug.
Just one thing, I don't know if you've seen, but it's actually doing the same thing as we were doing in Unite. If you show me the inputs for the sign up,
Yeah, this one
that
is.
wasn't very usable.
Yes, so at the heart of Bugbuster we have Unite. So it will figure out input like this one, for instance. We have a regular expression which is a bit more lousy than the one in the example I showed. And by just putting a dot at something, the validation goes through, but the server refuses the validation. That's why you have a 400. So if you go to the bug section, you have a list of bugs that are listed here, and we can choose one. For instance, this one looks interesting, so we'll go on the last one, this one. And we get some information, like we can go to the code. So we don't see the highlight because I guess the
It's there.
projectors.
It's showing up.
Oh yeah, it's barely visible there. So we see that there was a typo. So we did the HTTP request, and in the fail function, we tried to show something, but we missed the O there. So that's a trivial problem. We can decide to create a report for that. So we click on the report this bug. Yeah. And write something like typo missing. Let's call it critical technical problem, and we create the report. And then we can also, we will do a lot of those test sessions, and the test session is one instance of your application where the robot started to explore your application. So what we can do is, each time we see this very same bug appearing, we will add that to the bug report we create. So we have a history of the different problems. So let's do that. And then we have a bug report where we can, this is a very simple bug report where we can, okay, this is open, it's technical, critical, and we have the information we had before. And the more session you will have, the more item in the list you will get here.
What browser is the logo running?
So we use WebKit, but it's not it's a heavily modified version of WebKit. So you will get the same result as in Safari or Chrome. But we don't do cross-browser testing. We are concentrating on technical testing and functional testing. For cross-browser testing, you would probably want to test less but more specific elements, and for that you would use WebDriver, Selenium.
Is that a part of your plan or is it?
Yes, it's not part of our plan to tackle the WebDriver testing as a whole, but what we want to do is an export functionality to WebDriver. So you can generate a well-bound test scenario from Blockbuster, and when you're happy with it, you can export it to WebDriver. But this will come later on. That's another feature.
There have to be some work actions.
Okay.
So much of sorry.
No problem. No problem.
We
So-
can get up to
Okay. Yeah, sure. Let's. Now, let's go back to the exploration, and we had this problem where you try to enter an invalid DA address, and you have this 400, and then you have this typer. But to reach this point, you have to do a lot of exploration. So if you just want to verify this property, that's probably too much to start the exploration from the beginning. So we can limit the exploration to a component. So to do exploration only on a component. So let's try to do that. We'll go to the kitchen sink, and we want to see what is the CSS selector on this element. Oh, sorry. So you have two ways.
So we have a website. First, you sign in before you can actually do anything.
So if you have basic authentication, you can just give the authentication in with the URL. If you don't have that, you can provide either a small script that I will show, which just tell the robot, this is the login, you put that as a username, you put that as the password, you click on sign in, and then you let it free. Or we can also use what we call a data set. A data set is just a grid of data that associate CSS selector with a string. So you could have, if you have an ID for the login or the password or whatever selector for those, you can just give this information.
If you have an example.
Yeah.
I do have an example.
Okay.
I do have an example for the kitchen sink, because there is also a sign.
The sign in.
Mhm. So here I just want to focus on this element, and it should have an ID. Yeah, this one. It's a sign up. So I will create a new scenario. So if you want to go back to the main scenario web page, so if you are in the exploration, you have a link to go back to the scenarios. And we will create a new test scenario. Yeah. And this will be the sign up. And since I want to focus on the components, I will not use the simple URL. I will use a script that we call the conductor script. And what you see here is strictly equivalent to using a URL. So what we do is we have this test session. We create a window on a specific URL, which is the kitchen sink Blockbuster, and we set the property auto explore to true. So when we do that, the robot will start to explore the application. What I want to do here is just inform the robot that it's okay to explore, but I want the robot to explore only this element, only the sign. So I tell the robot that it's boot elements, it's not body anymore, it's the sign up form. Then I will save. And from here you can also start the session. So when you're ready, I don't know if you had time to copy this boot element selector. It's a CSS selector, by the way.
That can be anything. That should be idea or anything you can
You
if
can
you have two multiple forms in a page.
Then it depends. Well, our system is really based on CSS selectors. So if you are able to identify one form or the other, you can start by exploring the first form, and when the first form is explored, you can change. This is dynamic. You can change in your script these root elements for the second form. But if you have two forms, you might want to do two separate scenarios so that you know that when you look at this, the first scenario, you are focusing on one form, and when you look at the second scenario, you are focusing on the second form. And it's up to you.
In general, it's a good idea to split things. If you create scenarios that are too complicated, it's exactly the same when you write unit tests. It's difficult to track what's going on in a very complicated unit test, and it's very difficult to maintain. So if your two forms are separate things, then just build two scenarios. If you do the same thing, then you have a complicated case to begin with, so you can do it dynamically, but it's good practice to split things.
Okay, so we'll start the scenario by clicking on the start button there. And now it starts as before, just open a new window, load the page, but then it goes directly to the sign up form as we saw before. And it generates all the different interaction that it can do on this scenario and stop there because nothing else can be explored. And you see that now it recognizes the bug. It's not the undefined is not a function anymore. It would write there's an icon specific for the severity of your bug. I set it to critical or something like that, and then if you write typo missing so by the way, when you use complex scenarios with more logic than what we are doing here, the session log becomes quite interesting. So the session log will tell you exactly what the robot is doing. So it starts the exploration, build the kitchen sink. Then it won't work on its own, so nothing is recorded, but when it finishes everything it can do, it will say no more event to execute, then stop the exploration. You can put stuff directly there by using console.log in your script, and this will appear there. Okay, this is for the exploratory testing phase where you let the robot free on the whole web application or open on a section of your application. But when you need more control, for instance, to log into the system or to do something more specific, like the first example I showed you, you need to use what we call the conductor API, and I want to show you a bit of that. So with the conductor API, what you can do is give very specific direction to the robot. You can also tell the robot to, for instance, focus on a component that's part of the conductor API. You can tell the robot to not click on some element. You can blacklist elements. For instance, if you sign in into your application and the first thing that the robot does is clicking on the sign out, it's not very interesting. So you can black out the sign out button and do stuff like that. And of course, you can do functional testing. The robot will give you technical testing for free. So if you have HTTP problems, if you have JavaScript errors, exceptions, this will be reported for you as a bug. If you have functional business logic problems, then you have to anchor them in a way, and I will show you how. So to do so, I want to introduce three main concepts of the API. The first one are the actions. This one is fairly easy to understand. You can ask the robot to do some action. You can ask it to click, type, select, and do other actions. So the difference with WebDriver is that those actions will be queued per window. And the robot will wait for the view to stabilize between two actions. So what does it mean? It means that if you log in, so you type the username, you type the password, click on sign in, log in, then you probably will see a spinner or something to wait until the page appears on the browser and you can start to interact with it. So the robot will wait until everything is loaded before executing the next action in the queue. So you don't need to take care of the synchronization issue, making sure that this element has appeared, that element is appeared. No need for explicit wait. So this is an example where you log in. So you have here you have the boilerplate that I showed you, and here I will maybe remove the color. Here you do the sign in. So you have the window there, and you click on the element, you type the username, you type the password, and you click on the sign in button. You see that it's chainable, so it's easy to add more action. It's very compact. And if you have, for instance, somehow a validation somewhere and you have to wait for something, maybe in the kitchen thing, I think it's the case. When you click on sign in, I can show you that. Yeah. When you click on the sign in, you have a form that appears. And you don't need to wait for this form to appear. The robot will know that you click there, something is happening, so it will wait for this form to appear. And then you type, and click.
That's one of the main differences actually with WebDriver, right? Where you have to code the waiting for the time. So since we are in WebKit, we try to know what's going on, and that helps you simplify your script.
One thing that you might have noticed if you know already WebDriver was the Google example. There's a good reason why we use Google as an example, because it's the website is so fast that in between the click on search and the search result, the latency is very short, so you don't need to explicitly wait for the next page to appear. But this almost never appears on your application. You have to anchor an explicit wait for the next page to appear, otherwise you will have, in the best case, it will always fail. In the worst case, it will pass some time and fail some other time because there was some latency. This will not appear again.
So, how is this going to behave when you have the window in front of the main window?
You
Ajax transition where when you click on sign in, you have a pop-up.
Yeah.
And how is that going to be handled?
You will have a queue of actions per window. So if you click on login and you have another window that appears, then this window will you will get an event in your script. It's an event editor, so you can get information when a new window is created, and you can start working on that window. You can.
Do we have to handle that explicitly, or is that?
Depends if you want to do specific things on the window or not. If you just want to explore, then if there are new windows, then it will explore one window at a time. I think it does run robin, so there's one event in the window, then another in the next window, and so on and so forth. But on the conductor API, you get events. Typically, we have the case where you have to click on login, then you will get a window with the username password. So for that, we had to interact with the second window, which was actually closing itself when you were logging in. So you basically
change those fields.
But then if somehow you, in the exploration, you log out or you come to another login form, it will not handle that. This is purely imperative now, that example in this case. It's basically loads, click, type, click, and then it goes automated.
And just auto explode through kicking then.
It kicks in right from the start, but since the script is executing first, you're putting actions in the queue that are executed first.
As the owner of the script, you always have the priority in front of the robot. So if the robot is doing something, it will finish doing whatever it is doing, and then it will give you back the control. I will show you how. And then you can insert whatever action you want to do. The robot will execute all those actions, and after that, if you decide to let it free, so you don't put other action in the queue, it will continue from there.
Actually, every time it sees a page, it first looks into the queue to see if you've queued something, like in that example. If you did not, then it decides to do something on its own.
Then the next concept I want to introduce is the concept of watchers. So the watcher is a way to detect the application state. And you can do that based on different predicates. You can do that by just encoding the URL. So if you have a specific URL, if you want to see if a specific element in your DOM has changed, or maybe you have an element that appears and this is what you are interested in, or if you want to be called when an element is not in the page, you can do that. And finally, if this is not sufficient, because those are like sugar to help you, you can also provide an application-specific logic, just a function that will tell the robot if the state of the application is the one you're interested in or not. So I will give you an example there. Imagine that you have an application like this one, and you want to know when the working head appears. You can do that in different ways. So there you have the window, and you ask it to watch a specific element. So it's a watch, and then you give a hash, and you say with elements, you can have one or multiple elements. Dot spinner, that's the spinner in the middle of the window I showed you before. And then you have a few functions that you can register. You can register for before, so this function will be called as soon as the spinner appears, and it will be called just once. As long as the spinner is there, even if you have the state that changes of the application, it will not be called again, it's just the first one. You can call the inverse, it's after, so when the spinner disappears from the page, you will be called. So this will be called when the spinner disappears. And the match will be called after the before callback. And then every time the spinner is there and the application state has changed. So maybe you can imagine that there's the spinner that appears and the page is constructing behind. So you have an element that appears, that's a new state. So the conductor is called and you can act on this as long as you register a function there. But before will be called just one. The spinner appears, even if the page changes, it will not be called again.
So then that was your question about how you want. That's how you watch things.
And the last concept I want to introduce is a goal. This one is trivial to understand at least. The goal is a promise. You just create the goal, and the goal can be fulfilled or rejected. And all the goals that are explicitly rejected will be marked as a bug. And all the bugs that were not fulfilled at the end of the session will also be marked as a goal. And I will give you a good example of a goal. If we go back to the same window, you have this head. In fact, this is a true example. That's something we need for customers. So you have this working HUD that appeared, and there was a bug there. This working HUD was never removed from the page. So things was staying on the page. So what we sometimes, yeah. So what we did is we created a simple goal. So we created a goal, my goal. We had this page, and we listened for the spinner just like before. And so we have the watcher. When the watcher begins, I will remove the color, it's easy to read. We create a goal, and a goal is really, it's the simplest thing that you can think of. It's session.goal, and you give a string, whatever string it is. It should define this is working HUD should be removed, if that's all. And the application will continue, the robot will continue to explore the application. And at some point, if the watcher called me after, so it means that the HUD was removed from the page, you will say my goal is fulfilled. And in this particular example, this function was never called because the HUD was never removed. That's a way to encode something that should happen. And if this thing does not happen in your code, that's the problem. So this is the goal. Now, if we put it all together on the kitchen sink, this is an example where we load the kitchen sink with Auto Explore. We create a goal saying that the signing goal, so signing should work, simple code. We do the action by doing click on the signing, we type username, password, and we click on the signing button. And normally, if the element signed in appears, then we fulfill the goal. There's a small difference here. I call the begin once. It's, if you are familiar with event emitter, it's the once function, and the event emitter is on, once, on different variants of it. The begin, after, match, they are just sugar around the event emitter, so if you prefer the event emitter function nomenclature, you can use it. And if you do that on the cursor on the kitchen sink, you will see that it's never reaching this point because there's a bug in the signing code. Okay, that's all the different concepts I wanted to introduce. So you can use your own code. We can help you on that. There are a fairly complete documentation here on app.buckcursor.com, but it's easier to access it from the applications. So Buckcursor. Then in the upper right corner you have the API. Another thing I want to highlight is here we have this nice widget to give feedback, to give IDs, and if you need support, I think you can feel free to use it to add more functionality that you would like to see, or if you need our help. Let me go to the API documentation.
Maybe you can show the down query.
Is anyone using this?
Yes, we have about 300 users, but it's still the beginning, so we're still very much processing feedback, which is things that we don't support. Just this morning we got a request from somebody who has an application with maps and he found 6 bugs, he was happy, but then he wanted more things about the mapping thing, so that's something we don't have much experience with. So yeah, so that's why he was showing the support widget. Not many people are using this support widget. So if you have questions and stuff, it's a good way to contact us.
Actually, that was my next question. What is it that's not supported? So, for example, we just getting started with this. I'd like to use it. From your experience, what is not supported right now?
Number one thing that people sometimes ask for is Flash. But if this is a web cloud, I hope you're happy that Flash is going away. You're happy that Flash is going away. So no Flash. In general, plugins won't work. Plugins, if you have other type of plugins, native, I think Chrome is now pushing forward.
Everything which is web will work. If you have videos, this will not work. It will not stop the exploration, but the video will be
It
just
will be a black square.
square.
SVG, it will do things with SVG, but essentially where you have events, it will not. Yeah, it will not very
So the way it's supported going to occur because the SVG will be rendered, but the robot will not take the different elements from your SVG as potential action that it can be. That's still missing.
So, pure JavaScript.
Hmm?
Pure JavaScript.
Yes. It's running in WebKit with the real production, it's JavaScript core that we're using. Unite and WebBugbuster, they're both working on the same foundation, which is a heavily modified JavaScript core. So production code will run with that. There are places where it will be slow because the instrumentation that we do for figuring things, so it will slow things down. But luckily, this is not something you need to stare at while it's working, so you can let it run. Now I had something else in mind that was important.
Anyway, if you find something that should work and doesn't, you just contact us and
Yeah, we
do that.
regularly actually write scripts and examples for people who are asking us. We do that happily because first it helps you, second it helps us figure out what needs to be done.
One comment I just wanted to make about the API is that we built this this conductor API in a way which should be fairly familiar with web developers. So there's a lot of event emitter. It's based on event emitter 2. If you know this project, it's really close to Node.js event emitter. It's pretty much an extension of it. We have also a DOM query API, which is just like jQuery. So if you want to test something in your web page and you know jQuery, you already know how to pick an element.
There's an example that's the
Yeah, in the documentation.
Yeah, just search for it. So when you run this conductor, it's a JavaScript context on its own. It's not running in the web page, but we have APIs to help you inspect the web page. That's an example of the dark query. It's basically like jQuery. So if you want to find stuff and iterate over elements and things, you can do that really easy.
Yeah, you can do simple stuff like $, and then you get the selector. You can be more specific if you have more than one window. You can name the window, so window.find, and you find the element you want. You have all the nice features from jQuery and other libraries like filtering and parents. So you can go back. We support frames. And it's a fairly complete DOM query API that you can use. That's very convenient to use.
Yeah, a few other things about invitation and things to come. If you go in the interface, you will see that you have coverage reports. So it shows you what lines have been covered and what lines have not been covered. So that's basically something to help you figure out if it did a good job covering or if you need to help it more and stuff. We still have issues with that, so don't be surprised if the coverage looks funny. So we have issues with that, something we're working on. The other big feature that people are asking for is a way to connect to a local server. So this is in the cloud. It accesses servers that are publicly facing. But if you yeah, well, we're building a tunneling feature into the product. It's not going to be SSH. It's actually going to be a WebSocket tunnel. But it's coming. We were hoping to have it for today. We didn't make it, but it's coming soon. So then you'll be able to connect to your laptop or to whatever server is within your private network. The last thing I wanted to mention, we promised on the proposal for the workshop that participants in the workshop will get a special account to Bugbuster. There is no such thing as special accounts right now because it's free. It's in beta. However, when we will launch the commercial version later this year, If you send us an email, we'll extend the free trial significantly for all participants of the workshop. So if you want to get that running, just shoot us an email, support@bugbuster.com or myself, and we'll do that.
Related question.
Yes.
So when it does become commercial,
Yes.
do you have an idea of what kind of pricing it will be?
The current pricing plans that we have in mind start at $50 per month for unlimited use. So it's not like, I don't know if you've used other testing services in the cloud where you pay per minute. Here you basically rent a robot full time for $50 per month, and then it goes up with various different features.
We're not exactly clear on what feature we're doing, what plan for the moment, as you can guess. But it was important for us to offer from the first plan an unlimited access, so that you can use it as much as you want. You don't have to worry that because you use it a lot in the beginning of the month, then the bill will be. No, it's fixed, you know how much it will cost.
That's the cool thing about this robot, right? It can run by itself, and sometimes it runs for a long time. So it's actually nicer if you can.
So signing up for an active session does not terminate the report at all.
It does.
It's synchronous.
No.
Yes.
Yeah.
Well, when you
sign
start
up,
the
the
robot,
robot keeps going.
sorry.
It's asynchronous.
Yes.
So you don't need to be online staring at it. So we still have that.
Yeah, we do have a REST API, so it will be documented, publicly documented in the coming months. Well, we need still to stabilize it. I know as a developer, there's nothing more annoying when you start to integrate something and you change completely and your integration is there. So we want to make sure that we have a fairly stable API before coming up. And we have a plugin for Jenkins, which is pending.
Yeah, we've submitted it, not approved yet. So you can start in your integration and stuff in Jenkins. You can have a build step to start a scenario on Blockbuster and look at the results. And similarly, we're working on integration with Jira and GitHub to send the bug reports directly to Jira and GitHub. So eventually, when everything will be there, once you're set up, you can actually have everything running in the background from the CI to your bug tracker without even having to go on the bugbuster.com.
A good starting point would be in the documentation. We have some guides and you can read the first beginning starlet. It's fairly short and it explains pretty much in less details what we said today, but it's a good reminder. You can make them, you can follow the script. It's not long, it's a lot of numbers. Okay, so if you have any question or if you want to try something, yeah? You can click on the name.
Thank you.
Yeah, it is.
So, I set up the element which
Huh?
this is